the Metabolite revolution. Mapping the future of personalized medicine, the completion of the world's largest metabolomic study by the UK Biobank marks a transformative milestone in medical science. By measuring nearly 250 metabolites in the blood of 500,000 volunteers, researchers have unlocked a massive dataset that could fundamentally change how we prevent, diagnose, and treat disease. While much of modern medicine has focused on the blueprint of life, our DNA This study shifts the focus to the real-time operation of our bodies. Understanding the power of metabolites. To understand why this matters, one must distinguish between genetics and metabolomics. Genetics, the blueprint, DNA tells us what might happen based on inherited risks. It is static and does not change throughout your life. Metabolomics, the real-time status. Metabolites are small molecules produced as your body processes food, air, medication, and stress. They act as a real-time snapshot of your internal biology. Because metabolites respond to lifestyle changes, illness, and environmental factors, they bridge the gap between our genetic predispositions and our actual physical reality. They reveal what is happening in the body right now, offering a much more dynamic view of health than a genetic test alone. A dataset of unprecedented scale, the UK Biobank project involved 50,000 hours of testing and a global collaborative network. The resulting dataset is uniquely powerful for several reasons. Multi-layered integration. These metabolic profiles can be cross-referenced with whole genome sequences, protein biomarkers, lifestyle data, medical records, and microbiome information. This allows scientists to see how genes, environment, and metabolism interact. Longitudinal insights. Because 20,000 participants provided a second blood draw 5 years after their initial test, researchers can track how metabolic markers shift over time. Proven clinical utility. This isn't just theoretical. Early findings from this research have already produced diabetes prediction. Blood tests that predict type 2 diabetes risk are already in use in Finland and Singapore. Heart disease detection. New methods to identify high-risk individuals years before a clinical diagnosis. Mental health links. Insights into how metabolism and gut microbes influence depression. Biological aging. Metabolomic clocks that estimate an individual's biological age versus their chronological age. The shift toward predictive medicine, this breakthrough accelerates the transition from reactive medicine, treating symptoms after they appear, to predictive medicine, intervening before disease develops. By leveraging this data, the medical community can move toward a model of precision intervention. For example, if a specific metabolic pathway is identified as a driver for a disease, pharmaceutical companies can develop targeted drugs more efficiently. Furthermore, these markers can help explain why two people with the same genetic risk might have vastly different health outcomes, likely due to their unique metabolic responses to their environment. What this means for the future of healthcare, while this massive dataset is currently a tool for researchers, its influence will eventually reach the average patient. In the coming years, we can expect earlier warnings, blood tests capable of flagging risks for heart disease or diabetes 5–10 years before traditional symptoms appear, hyper-personalized nutrition, diet and supplement plans based on how your specific body processes nutrients, tailored treatments, medications and lifestyle interventions customized to your unique metabolic profile. We are entering an era where your health story won't just be written in your DNA. It will be shaped by the dynamic, ever-changing signals your body produces every single day. Conclusion: the UK Biobank study provides the missing link between our genetic potential and our daily physiological reality. By mapping the metabolome at scale, science is moving toward a future where disease is anticipated and prevented through deeply personalized, real-time biological insights.